I'm Ahmed Dawood, and in this session, we are going to start to discuss performance measures for the binary classifiers. So, in the last sessions, we have explored sklearn or logistic regression class by sklearn in very detail. So, in this session, we will discuss accuracy and confusion metrics, and in the some coming sessions, we will also discuss some other performance measures for the binary classifier. So there will be no such a uh, tough coding in these sessions, and we are not going to solve some problems or to evaluate some actual model. Here we just will take concepts in these sessions. Okay, what are the concepts behind some buyers? Okay, so regarding coding, there is no much difficult modules or formulas of the performance measures that we are going to discuss. So you can also do code for these formulas or measures, and also these measures and their functions are available by sklearn. You can also import them. Okay, so when we will go on the Jupyter notebook. So we will use this file in which there is no independent variables, just a dependent variable in the form of true values. These are the predictions by some random classifier. Okay, and these are the probability for the class one. If I will zoom in, these are the probabilities, and we have discussed that we usually do in that way. These are the actually p cap. P cap gives some probability for the class one, and we have discussed that in general way, or we usually classify our samples in that way. If our probability is greater than 0.5 or equal to 0.5, we classify as a class 1. Here you can see it's a 0.69, and here it's classified as a class 1. And if the probability is less than 0.5, we usually classify as a class 0. So first of all, we will discuss accuracy, and we also have used that accuracy by the score function of model logistic regression. So accuracy is the simple, or you can say very easy measure, and how it calculate the very easy way in this way. Yeah. So there are number of correct classifications out of all the classifications. Okay, out of total number of samples that we have evaluated. Let's say we have these are the true values, and here our some model has predicted in this way uh, against this sample 0 0 0 1 1 0 0 0 1 0. Okay, so there are total 10 samples in uh, this data set, and actual values are these green one, and sorry, these are the actual values, and these are the predictions. Okay, so if we want to calculate the accuracy for that uh, model that has predicted this prediction. Okay, so how we can calculate the accuracy, how many number of times number of correct classifications will be on the as a numerator, and in the denominator number of total samples. Their total samples are 10. So 10 samples we have evaluated: 1 2 3 4 5 6 7 8 9 10. 10 samples we have passed to that model that has given that prediction, and against each sample we got that predictions. Okay, so out of these 10, there is just one prediction that is classified misclassified, and 9 predictions are correctly classified here. So there are total correct classifications are 9 out of 10. So here it will be 0.9 or 90%. Okay, in this way, this is very easy, and I hope you already know that yeah, how to calculate accuracy, number of correct classification divided by number of total samples that we have used. Okay, so what is the flaw in the accuracy? when you have seen some performance measures regarding the binary classification, you will see some multiple uh, performance measures, and accuracy will not give you always the correct measurement regarding the assessment of a model. Okay, it's always not a good measure to evaluate some model or to assess the model. What is the problem in that accuracy? First, we will discuss this case. Let's say we have very dumb model that is just a negative model, and any sample we will pass to that model, it will classify as a zero class. Okay, so all the predictions here are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All the predictions here are classified as zeros. Okay, so there is dumb model, and out of all the true values, there are just two values, this fifth one and this ninth. These two, one, two, three, four, five. This is misclassified and this is misclassified. Means total correct classifications are 8 out of 10. Okay, and your accuracy in that case is 0.8 and means 80%. Now you have seen you are using very dumb model that is just a negative model. Any sample you will pass to that model, it will give you uh, the negative class, it will predict negative class. There is no computation behind that model, there is no some such sort of we have done the training here, and there is no or any other effort you have put in that model. It is very dumb model, and any sample you will pass to that model, it will predict as 0. But your accuracy measure is saying that it is 80%. This model is giving you 80% accuracy, means this measure is saying that your model is quite good, but actually you have seen that it's a very dumb model. Okay, in that type of scenarios, accuracy fails, and we cannot use accuracy in every case. So then what we can use to evaluate our binary classifier? How we can assess our binary classifier? So first of all, we will discuss a very common matrix, which is confusion matrix. So confusion matrix, in the coming session, we will discuss what are the some other measures, but confusion matrix we usually use to discuss the performance of binary classifier. Okay, so a much better way to evaluate the performance of a classifier is to have a look on the confusion matrix. So we will discuss what exactly this confusion matrix represents. So before that, usually we will see that on the many sites about the confusion matrix, and people are most of the cases people are using that matrix. Okay, and other if you will understand the confusion matrix very well, then you can also can get understanding about the coming performance measures in the coming sessions. Okay, so first of all, we will see. mm, Okay, so here, this is our the code that we will use. Just there is not very uh, strict algorithms here we are going to use, but we are just importing the functions from the sklearn and we will use that. Okay, so this is the Okay, this is the data frame in which I have imported my Persian recall .csv file that I have discussed here. This file I have imported here in that data frame, and here you will see. Okay, so there are total 300 rows in that. Means there are total 300 samples we have. Against 300 samples, we have true values, we have predictions of random classifier, and there are some probability of the class one. Okay, so if we will use confusion matrix here, I have imported from sklearn.matrix. If we will use confusion matrix, and we will pass true values and the predictions, this will give us this type of two-dimensional array. okay, in which we have usually four values. So before that, I want to show you here how many true values, these are the true values column, and how many, okay, how many number of zeros, zero class, and how many number of one class values we have in that column. There are 209 values in that class. In that column, there are 209 values are zero, and there 91 values are one. In other words, you can say 209 samples are zero belongs to zero class, and 91 samples belong to uh, the one class. Okay, so these are actually true values we have. Now, what about the these are the predictions, and these are predicted by some classifier. How many values it has predicted as zero class? 261 samples it has predicted as a zero class, and just uh, and 39 samples it has predicted as a one class. Now we will see that values by using this confusion matrix. Okay, okay. So first of all, usually we have predictions on this side. Okay, before that, here you can see the actual values are on this side. Okay, 0 1. Here you can see you have a matrix in which 185 2 4 one array, and the second array is 76 and 1 5. Okay, so this array you have here. Now for actual values, how many actual values are here? Actually, how many samples are zero? Okay, you know here in the true values you have 209 samples as belong to zero class, and 91 samples belong to one class. So here 185 to 4, when you will add both of them, this will be 54820 samples. Okay, so here 76 15, and when you will add both of them it will be 191. Here you have seen that if you will calculate your sample in this matrix along this direction you will calculate, you will add the values along this direction. Okay, you will get your actual samples that belong to zero class and actual sample belong to one class, means you are getting your true values here. Okay, these are your true values. Now if now if in other case, let's say here, in other case, in the in that direction along the column wise you have here 0 and 1. These are the predictions. Okay, so prediction done by your model, or you can say this on this side you having your predictions column. Okay, predictions column, you have the values of prediction column. Here you have seen how many times your model has predicted as a class 0. When you will add 185 plus 76 you will get 261, and when you will add 24 plus 15 you will get 39, means your model has predicted 0 class 261 times, and one class it has predicted 39 times. It means your predictions column have 291 or 261 zeros and 31 ones. Okay, now you will see here, you can see here when we have used the value count, you can see here 261 values are 0 and 39 values are the ones here. Okay, so you got an idea along the column row wise your actual values, and along the column wise your predictions. Now, why they are in the form of two-dimensional array and why there are four values here. Okay, so we will discuss in this way. You will have that type of box, and here you have actual values. Okay, actual values, and these are the values that are actually belong to zero class. These values and these values that actually belong to zero class, and these boxes, when you will add these boxes, these are the values that actually belongs to one class. And predictions you will have on this side along the column wise, and here you will have 0 and 1. Now if your model has predicted as 0, okay, so for that we usually consider as a zero class as an active, okay, as an active class, and one class as a positive class. Okay, so here when your model will predict 0, it means you are predicting negatives here. Okay, so if your negative, your model has predicted as negative, and your the prediction is also, or true value is also negative, then it will become true negative. Okay, so if your model has predicted as negative but actual value is false, actual value is positive, actual value is 1, then your model has done wrong prediction. It will become false negative. Here you will see, if your model has predicted as a one class, it will become a positive. If predicted as a one class, these are the positives. Okay, now if your model has predicted as a one class but actually these samples, these values are belong to zero class, then your model has done wrong prediction. It will be counted as false positives. And if your model has predicted as a one class but and actually these are the actually ones, a true value is also one, then it will be considered as a true positives. Now you will have four type of values. Okay, like in our case, in that model, if I will show you here, okay, in that case you will see that your actuals are on this side 0 1, and your predictions will be on this side 0 and 1. Now this number of the predictions that are true negative, your model has predicted 185 samples as negative, and these are actually negatives. Now your model has predicted 76 samples as a negative, but actually these are positive, so it will become false negative. Here your model has predicted 24 samples as a positive, but these are actually true. Actually, these are actually belong to zero class, so your model has done wrong predictions here, so it will become false positive. So here your model has predicted 15 samples as a positive, and these are actually positives. You have seen from here, these are actually positive, so this will become true positive. Now you will have four measures here: true positives, false positives, and in other way you can say here true positive, false positive, true negatives, and false negatives. You have these four measures here. Okay, four values. So these four values, these four measures usually you can see in the form of confusion matrix. Okay, in one in you can see in the form of two-dimensional array. These four you can see. Okay, so here this confusion matrix, keep in mind, as I told you, in when you will go on some you will read some books or go towards some sites, and you will search the confusion matrix on some other sources, you will see that confusion matrix will have some different types of directions also. Let's say if I will show you here, Here you can see that there are confusion metrics, and they in the on the internet you will see that there will be multiple confusion metrics, and in each confusion matrix they have changed the directions of presenting their values. Like here they have actual values on the along the columns and predicted values along the rows, and again they have positives on the zeroth position and negatives on the 1st position, and on the other way in the actual value they also have in this way. But here your aim is to just if I will use this one also here. Okay, so if you will see in this way, you don't need to worry about that in which direction they are for presenting your actual values and prediction values. You should have the concept. Okay, now here if they have the confusion matrix, someone have confusion matrix, or on some source you have confusion matrix like this, how you can judge that which box can represent which type of, which box is representing true positive and which box is representing here true negative. Okay, the simple way is along the positive, these are your predictions, so you have to start from the side of predictions, and these are the positives. So these boxes are the uh, boxes that are representing here positives here. Okay, positive samples, your model has predicted these samples as positives. So these two boxes will belong to negative class. Your model has predicted these as a negative class. Okay, these samples as a negative class. So when you will refer the actual values to evaluate either your model has done the true predictions or false predictions. So first of all, you will see that from here your model has predicted some samples as positive, but these are actually positives. So this will become true positive. Now your model has predicted some samples as a negative. Let's say here your model has predicted some samples as a positive, but these are actually negative, so this will become false positive. Now your model has predicted here as a negative class, but actually these are positive, so this will become false negative. Model has predicted here as a negative class, and these are actually negative, so this will become true negative. In this way, you can mark the values in which form the confusion matrix is present. Here you just have the concept how you can categorize that this box is representing which value. Either this box is represented true positive or true negative, or which metric this box is representing here. Okay, so no matter on the sources, different sources, there will be multiple. This if you will rotate this, let's say if you will rotate this now, or maybe you will find some difficulty. But if you will use your concept, you can easily mark the values that this value is representing which metric. Okay, so now you have got an idea what are the how confusion matrix represent the different four values or four matrix. Okay, now one other important aspect is here that we have two type of errors here: false positives and false negatives. Okay, these are the true positives and true negatives. We always satisfy with the true predictions, but we have to increase the predictions or accuracies or our score of our model, we want a minimum number of false predictions. Okay, minimum number of false predictions. So we usually have two type of errors. One is false positive, which usually we call as a type 1 error. Okay, in which our model has predicted as a positive class, but actually it is not. Now the second type of error is type 2 error, which is actually the false negatives. Means that your model has predicted some samples as a negative class, but these are actually belongs to a true class or positive class, sorry. So these will be categorized as false negative and we usually call as a type 2 error. Okay, you will see on some uh, sources that people are using the type 1 and type 2 terms. Okay, so whenever you will see type 1 term, it will be they people at that place will be talking about false positives, and if you will see type 2 error, people or the persons where are discussing about the false negatives. Okay, so confusion matrix and how you can use that confusion matrix, you will see here. Let's say you are considering this same dumb model here and the same dumb model that has done the negative predictions, but here your accuracy measure is saying that this is 80%, accuracy is giving the score 80%. It means it according to accuracy it is good model, but when you will see that y cap, this dumb model, this negative model in the form of confusion matrix. So here you will see, according to confusion matrix, your model has done all the predictions as a negative. There is no prediction here as a zero, as a one, sorry. There is no prediction done by the model as a one class. All the predictions your model has done as a zero class. Here you can see it. Out of all the predictions your model has done as a zero class, there are eight predictions that are the true predictions, and there are two predictions that are the false predictions. But here on this side you can see that this side is zero. It means your model is not good here. Model is you can easily get an idea that your model is dumb. It is just a negative classifier. But if some person will show you the that your model is giving you the 80% accuracy, you cannot judge that your model is what type of your model is. Okay, is it a good, is it a what type of model, is it some dumb model, is it some intelligent model? So you cannot analyze, but if some person will give you some confusion matrix, you can get an idea of what type of model it is. Okay, so this is about the in this session about the today's session in which we have discussed that accuracy, which is of course you know already, and in the more detail we have discussed confusion matrix. So in the later sessions we will discuss here you have seen that we having four values here. Okay, so if we want to compare some models, if we want to judge the our model in the form of one score, here there are four scores. So how we can do that? How we can represent or can represent these four measures or these four scores in a single score? So we will see in the coming sessions. So for now, thank you.